Hey, everybody. So I know we're changing things up a little bit, but you know what? Still weekly Ed puzzle videos because you guys are earning it. You know, you're still getting it done. We have to go back to the old-fashioned organizer. So here it is. This is how you do it until I can figure out what's going on with Notion, why some people can't upload their files. This is a Google Doc with a table. And hey, I did this for 5 years. Okay, it works great. Got me through the whole pandemic doing these Google Docs. I even designed a company with it, but you know, the Notion is better, and this will work too. So what it, you know, so how do you do this? You just claim a row. We used to last year, some classes, we, you know, someone would post all this in a box, like you could say rank first place, then put your screenshot below that and description below that. So we can do that, or you can claim a row and do it like this. So yeah, if we do it like this, then this can be, so then you put your red, and don't choose the dark red, okay, because that's too red, it's too blinding. Just choose the nice light colors, and then this would be yellow, and then this would be your green column. So you could do it like that. So this is how some classes have done it in the past, where they claim a row, but maybe, you know, we could just take Tony Tiger's stuff, and we'll put it right there. So sorry, I'm changing it in the middle of my directions, but you know, better late than never. All right, so it's like that. Okay, so but you know, of course, now we got to even out the rows here. All right, so we'll just do what we can do. So this will be this. Oh, but actually, this would be Tony's green problem. So just put that green, yellow, red. But actually, this way, we can just have our column, ta-da, and yellow. And then it still is nice if I scroll through and I only see green column, green problems, you know, because I'm scrolling and I only see things on the right side, then we're good. And if I see anything on the red side, it catches my attention. So still the traffic lighting strategy there. And I hope that you enjoy that. But now let's get to the math. So we're doing set number 15 here, the Pythagorean theorem. Still talking about angles a little bit, but then we're going to get into the Pythagorean theorem. And you have the solving equations unit test, which I think you did in October. So it's January now. It's a good time to do that. It's called spaced practice since it's been a while. All right. So let's get to the first one, finding angles in an isosceles triangle. So in last week, we found angles using the triangle sum theorem. All angles in a triangle add to 180. But what about when you only know one of the angles? Well, that actually works if your triangle is isosceles. So make sure you look up scalene, isosceles, and equilateral. You don't know them already. I'll just tell you this: isosceles, two sides congruent. There you go. A little bit of helpful information. So that's what we know there. And so if two sides are the same, not only are two sides the same, but there's also a theorem called, in one year, we called it ITBAT, which stands for the isosceles triangle base angle theorem. ITBAT. And what does that say? That says if the triangle is isosceles, then the base angles are congruent. Not only are the two sides congruent, but the two base angles are also congruent. And so let's talk, what are the base angles? Well, this one is called the vertex angle, and it is where the two congruent sides meet up. That's called the vertex angle. And so the other two angles are the base angles. And so we know they're congruent, so that one is also x. So we got x and 70. So you guessed it, we just do x plus 70 equals 180. And that would be 2x equals 2x plus 70 equals 180, which is 2x equals 110, which is x equals 55. And that's what we want to know, 55. All right, now a little bit words of warning here. Just be careful that you know what your vertex angle is and what your base angles are. You know, here we have the base angles and the vertex angle is x. So that means this wouldn't be x, it would be 62 because the base angles are congruent. That, you know, if you have to learn that the hard way, you have to learn that the hard way. But that's how that goes. So, this is like something we did last week. Some of the worksheet problems looked similar. So we're going to need our vertical angles, our linear pairs, our linear triplets in order to find these missing angles. So when I look at this, well, one thing that I see is this angle and this angle are corresponding angles. So if we find the measure of this one, then we know the measure of x because corresponding angles are congruent, right? So you see the parallel lines cut by the transversal, which we did last week. And now, so you got to be able to spot those corresponding angles, those alternate interior, exterior, same side, interior, exterior. They're here. So let's find the angle C, and then we will know our value of x. So how we're going to do that. 54 plus 105 plus x equals 180. 54 plus 105 is 159, right? Plus x equals 180. Subtract, and we get 160, 180 minus it would be 20, 21. 21. So x is 21. All right. So there you go. Some good angle practice. Very useful. Angles are all over the place. But now let's talk about the Pythagorean theorem. And so what is that? That is none other than a squared plus b squared equals c squared. And we'll look at that for math practice Monday. On Monday, we're gonna make triangles and see why this works, but just the mechanics here. The first thing we gotta do is label A, B, and C. So C is always the hypotenuse, the side across from the right angle. A and B can be either one of the two sides. I usually like to make the horizontal side A and the vertical side B, but sometimes the triangle is not even vertical horizontal, so it really doesn't matter. Just as long as C is your hypotenuse, that matters. So we label and then we substitute. 6 is going in for A, 8 is going in for B, and C, X is going in for C. Square those numbers. 36 plus 64 equals x squared. Add our numbers together. 100 equals x squared. And now, let me just write that. So it is x squared equals 100, right? Do not divide by 2. Don't do it, because x squared is x times x. Well, the inverse operation of that is not division of 2, okay? This is a new inverse operation, although we have used it this year. We square root both sides. So x equals 10. All right, don't divide by 2. You'll be sad you did. It won't be right. We run into an error. Hey, multiple locations. No. All right. So the last thing we're going to do here is the Pythagorean theorem in isosceles triangles. How cool. So all we got to do for this one is we got to notice that the isosceles triangle, the whole thing here, is not the right triangle. And Pythagorean theorem works in right triangles. In essence, if I were to just block this out, I have a right triangle. But the base is not 8. I blocked out half the triangle, so the base is 4. Do you see that? And the height is x, right? So now I'm just going to go forward. A squared plus b squared equals c squared. X squared plus 4 squared equals the square root of 20 squared. Oh, okay, so now x squared plus 16, 4 squared is 16. And the square root of 20 squared is just 20. So those two things cancel each other out. I'm going to write it out like that. That is just 20 because the square root and the squared are inverse operations. Okay. So now we got x squared equals 4. Square root of both sides. What's the square root of 4? 2. X equals 2. And so x equals 2. So we got that. All right. Hey, successful day here at Mr. Fields' basement of math. So the Pythagorean theorem, triangle sum theorem, so important. Both of those things are so important. And solving equations. I hope right here. I hope that you do very well in this set 15 because it is all important topics that you will use this year, next year, and in every year of your math career to follow. And then next week, we're even going to talk about applications of Pythagorean theorem. This is just a great time of the year. All right, I look forward to seeing you guys in class.